Assalamualaikum, hi and very good evening. In this video, I will proceed with the skewness, which refers to the asymmetry in a symmetrical bell shape or normal distribution in a set of data. If you still remember about the normal distribution, or we call this one as a bell shape, when you have in terms of normal distribution, the bell shape is symmetrical. Actually, we have another two types of bell shape, which is negatively skewed, or it is skewed to the left, or it can be in terms of positively skewed or skewed to the right. There are three ways to determine the distribution or the skewness of the data. The first one is by using formula. The second one by visualization, which is by just looking at to the histogram. And the third one is by using box and whiskers plot. Let's look at to the first method, which is by using formula. There are two formula to determine the skewness or the shape of distribution. The first one by using Pearson coefficient formula, or it is known as PC. We can use the values of the mean and mode when we have this information, mean minus mode divided by S, or standard deviation. And the second formula, PC is equivalent to 3 times with the mean minus with the median divided by standard deviation. There are three possible answers for the Pearson coefficient because it involves the difference between two values. It's either the values of PC is positive, 0, or it is negative values. This is how you determine the distribution of the data. If your PC is greater than 0, your shape or distribution of the data is positively skewed. When the PC is exactly 0, meaning that the distribution is symmetrical, and the PC less than 0, meaning that your data is negatively skewed or skewed to the left. The second method is by using box plot. This is an example for the symmetrical. The values on the first box or this line is equivalent to the first quartile. The values here is equivalent to the third quartile. Since we have first and the second quartile, we can also identify the IQR or interquartile range. So the third quartile minus with the first quartile, then you will get the interquartile range. And we call this one as a whiskers or lower inner fence here. How can we get the lower inner fence? It is equivalent to the first quartile minus with the 1.5 times with the IQR. And this is upper inner fence. It is equivalent to the third quartile. So the third quartile is located here. So for you to determine the upper inner fence, it is equivalent to third quartile plus with the 1.5 times with the IQR. So you should know how to draw this box and whiskers plot, because from this box and whiskers, there are a lot of information that we can identify. Other than that, we can also identify an outliers. Let's say you have the data which lies above the upper inner fence. So let's say the upper inner fence, the maximum values is 500, and in your data set, you have the values of 1000, meaning that values of 1000 is the values of the outliers. We can also have the extreme values, which is extreme small values. Let's say this is your lower inner fence, and the lowest values that you can have is, let's say, negative 500. And in your data set, you have the values of negative 700. So negative 700 will fall before your lower inner fence. It should be negative 700 here, and this data we call it as an outliers. So this is one of the graphical technique to identify the outliers from the data set. And the third method here is by using histogram. So by using this histogram, so if you still remember the first slide that I showed you just now, it is about the symmetrical, and we can identify the shape of the distribution from the histogram. So let's say when we try to sketch the bell shape on your histogram, so you will get it is symmetrical, and the box will be something like this, which is 25% here, 25% here. And when you refer to the first histogram here, and when you try to draw the bell shape, it will be something like this. So it shows that the data is negatively skewed, or it is skewed to the left. And then when we try to sketch the bell shape on this histogram, we can see that the data is positively skewed or it is right skewed. And the shape of the box plot will be something like this. The difference between the Q2 and Q3 is higher than the difference between Q1 and Q2. And you can see here the whiskers on the right side is longer than the whiskers on the left side. And when you try to look at to the negatively skewed, it will be opposite to the box and whiskers on the positively skewed. Okay, let's try out some exercise here. The following data set represent the monthly income of employees at a company. So first thing first, what you have to do, you have to arrange your data in ascending order. So we have the lowest here, 2000, and we have 7,900. And of course, we can find out the first, second, and the third quartile. Let us try to identify here. We have the second quartile or the median is equivalent to 4,200, and this is our lower half, and the first quartile is equivalent to the average between 2,500 and 3,000. So from this calculation, you will get the first quartile equivalent to 2750. And this is our upper half, and the Q3 is equivalent to the average between 4,550 and also 5,000. Then you will get the values of third quartile 4775. Okay, now we try to find out the Pearson coefficient. In the formula of the Pearson coefficient, you don't need the values of first and also the third quartile, but we need that values for you to sketch the box whiskers on the next example. Okay, the question asks you to find out the Pearson coefficient of the skewness and describe the shape of the distribution for the data. We have two formulas here. Which formula is suitable for you to use? When in your data set, there is no mode or the mode is not significant, it is better for you to use the second formula. Like this example, we have no mode. All the data appears only once. Therefore, we will use the second formula by using mean and median. You have to memorize this formula because it will not be given during your test. Okay, so we have here, since there is no mode, we will use the second formula. 3 times with the mean minus median divided by standard deviation. Okay, since we have the values of, we need the values of standard deviation here. So we need to calculate first the standard deviation by using the formula standard deviation for the ungrouped data. So let's recall the formula. Summation of x squared minus with the summation of x squared over n over with the n minus 1 square root. From this calculation, you will get the values of standard deviation is equals to 1737.65. In the formula of Pearson coefficient with the values of mean, so we need to find now also the mean value. So mean is equivalent to summation of x divided by n. So from the calculation, you will get the mean is equivalent to 4127.78. So we have everything here. Then we can plug in the formula. 4127.78 minus with the median, which is our median values just now is 4,200 divided by standard deviation 1737.65. So you will get the values of Pearson coefficient negative 0.1247. So you can take 4 decimal point for the final answer. Then how can we describe the shape of distribution? So if you still remember, there are 3 possible answers for the PC. It's either it is greater than 0, equals to 0, or it is less than 0. So since it is less than 0, the shape of distribution should be negatively skewed. Or you can write down as a skewed to the left. So this is the how you describe the shape of distribution. Now let's look at to the example 15, and the data used here is the same data set like our example 14, we have to construct a box and whiskers plot for this data and describe the shape of distribution. So since we already answered by using Pearson coefficient, just now we get it is negatively skewed. You should get the same shape of distribution by using box and whiskers plot. So after you arrange your data in ascending order, then we already get the first, second, and the third quartile just now, because in order for you to sketch box and whiskers, you need to have all these values. So from here, you will get just now Q1 is equivalent to 2750, Q2 is equivalent to 4200, and the Q3 just now is equivalent to 4775. Since we have to calculate the lower inner fence and also upper inner fence, we need to have the values of the IQR. So IQR is equivalent to the difference between the third quartile and the first quartile. So the difference here is equivalent to 2025. So the lower inner fence is equivalent to the values of the first quartile, which is 2750, minus with the 1.5 times with the IQR 2025. So you will get the minimum values that we can have in the lower inner fence is negative 287.5. And the upper inner fence is equivalent to the third quartile 4775 plus with the 1.5 times with the IQR. Then you will get 7812.5. It is the maximum value that you can have in your whiskers here, or the lower or the upper inner fence. Now we can try to sketch. Since we have everything here, it's better for you to check the difference between the second and the first quartile, as well as the difference between third and the second quartile, to know which one is longer. Let us check the difference between Q2 and Q1. So Q2 is 4200 minus with the Q1 2750, and you will get the difference is 1450. And the difference between third quartile and the second quartile is equivalent to 4775 minus with the 4200. Then you will get the difference is smaller, which is 575, meaning that you can imagine how your box looks like. So you will get something like this. Since the difference is higher on the second and the first quartile, and you will have the smaller box should be here. Okay, normally when you have the longer or the bigger box between Q1 and Q2, you will have the longer whiskers here. So you will have something like this. When you look at to the data set, the smallest values is 2000. And from the calculation of the lower inner fence, the smallest values that you can have negative 287.5, meaning that we don't have the outliers on the left side because 2000 is bigger than the smallest values in your lower inner fence. And when you look at to the upper inner fence, the maximum values is 7812.5. But in your data set, you have the values exceed the maximum values that you may have in your upper inner fence. Therefore, in this case, we will have an outliers on the right side, which is for the data 7900. Okay, let us try to sketch our box and whiskers here. We already sketched just now, but you have to mark everything here. The smallest value should be 2000. And we have bigger box here, which is the Q1. The values of the Q1 here is 2750. The second quartile 4200, and the third quartile 20. And the third quartile here should be 4775, and we will have the whiskers on the right side here, and we have the outliers, which is 7900, but the maximum values on the whiskers here is the values of 5000. So on your box whiskers, you should have all these numbers, which is refer to the minimum values. And if you have the outliers on the left side, you have to mark the outliers. You must have the first quartile, which is 2750. You don't need to put as Q1. If you want to put it as Q1, is also can. Like, let's say I put that one as a Q1 here. And this is Q2 and this is the Q3. But if you don't want to write down Q1, Q2, Q3, it's okay. But you need to write down the values. So 2750, 4200 for the second quartile. For the third quartile, 4775. And the maximum values on your whiskers on the right side here is 5000. And 7500 here is your outliers. So when people out there look at to your box whiskers, actually without you put it as Q1, Q2, Q3 and outliers, they will know what is actually the IQR, the first quartile, second quartile, third quartile, the minimum values and the maximum values from this visualization. And about the shape of the distribution, from this box and whiskers, we can see that the whiskers is longer on the left side, therefore your bell shape will be something like this, or we can say that it is negatively skewed. And it is also proven by using the method of the formula from the previous example, which is example 14. By using Pearson coefficient, we also get the type of distribution is negatively skewed.